Hey! Today, we're going to talk about polynomials and zeros. We started the last lesson talking about polynomials in general, specifically how to name them based on degree and the number of terms, right? Remember, degree is the highest exponent in the polynomial. And looking at this one, I see a 2, so the degree of this polynomial is 2, which makes it a quadratic, right? If the highest exponent was 3, that would be cubic. If it was 4, that would be quartic, right? And then the number of terms. This just so happens to also have 2 terms, which makes it a binomial. If it had 3 terms, it would be a trinomial, right? So that's just a brief review of some of the things we had gone over. Today, we're going to focus on a very special concept, and that's the concept of zeros. So, zeros basically are x-intercepts or solutions to a problem. So think about x-intercepts, right? That's going to be where the function crosses the x-axis. And this could happen more than one time, as we'll see. Or you could think of it as the solutions. So if you think back to when we solved quadratic equations, right? Those solutions were the same as x-intercepts and are the same as calling them zeros. So what we're going to do is to kind of ease us into this, we're going to focus on an example using a quadratic function so that way we can relate it to things we've already done and then move forward from there. So what we're going to do is we're going to find the zeros of y equals x squared minus 9. A binomial quadratic. So we're going to find the zeros of this function. Now to find the zeros, or to find the x-intercepts, you set the equation y equal to 0. And this is something that's true all the time. You should have gotten that back in your Algebra 1 class. When you're trying to find an x-intercept, you set y equal to 0. If you wanted a y-intercept, you would set the x equal to 0, right? Because this is the y-axis and this is the x-axis, right? It doesn't matter where you are on the x-axis, the y value is 0. Think about what these could possibly be. This could be maybe 1, 0, and maybe this is negative 2, 0. Either way, do you notice on both points the y is 0? That's like the whole point of intercepts, right? So anyway, if my goal is to find zeros, then I need to make y equal 0. So all I have to do is literally take the y and I'll make it 0 equals x squared minus 9. This is how I'm going to find the zeros. But that's not all, right? Not only do I have to set y equal to 0, I also have to factor it, right? And again, this is what I was talking about when we talk about solving quadratic equations. If I want to solve this, I need to factor it. Now, x squared minus 9 just so happens to be the difference of squares. So, I can factor it. X squared is going to come from x times x. And negative 9, well, that's 3 squared. So it would be plus 3 minus 3. You can't get away from factoring, people. You are going to be factoring a lot next year. You're going to be factoring a lot in this section. It's just one of those skills that you cannot get away from in basically until you're out of high school. And even when you get into college, depending on what you plan on doing, right? But this concept here is incredibly important for next year. A lot of what I'm trying to do in this section is get you ready for next year. Because this is kind of how your year is going to start off. Anyway. Once I've gotten to here, so I set the y equal to 0, right? I changed the y with a 0. And I then factored the polynomial. So how do I solve it from there? Remember, if you have x plus 3 times x minus 3, and the result of that is 0, well, that must mean one of two things. Either this x plus 3 is equal to 0, or this x minus 3 is equal to 0, right? And then you just solve those equations. Subtract 3. So one of your zeros, x equals negative 3. And then if I add 3, one of my zeros is x equals positive 3. So the zeros for this function are negative 3 and positive 3. So again, remember what that means. If I was looking at a graph, you would have x-intercepts at positive 3 and negative 3. Now let's just think real quick how this graph would look, right? We do know that it's quadratic. We know that the shape of a quadratic kind of looks like a parabola. The leading coefficient is positive, right? That's like a 1x squared. So that means my graph should look something like this. Again, I'm not looking for 100% accuracy here because I'm trying to get us to understand the concept of these x-intercepts. Now, obviously, I could find the vertex to make it more accurate, but I'm trying to get us to understand the general shape of the graph. Now, if you also relate this back to the last lesson, we talked about end behavior. And that always depends on the leading coefficient. If it is even degree with a positive leading coefficient, the end behavior is up and up. Look at this graph. On the left side, it goes up. On the right side, it goes up. It increases going left, and it increases going right. Because the leading coefficient is positive, and the highest degree, or the degree, is 2, which is an even number, right? So all that end behavior stuff, you can't forget that either. But anyway, you can see how this isn't actually doing anything new. The only new thing is that we're now calling them zeros instead of the solutions, right? Before, I would say, what are the solutions of this, or solve this equation. Now I'm asking, what are the zeros? It's the same question, just asked differently, right? So that's a quadratic function. But what about polynomials that have higher degrees, right? So what we're going to do is we're going to look at this polynomial here. So, to find zeros of any polynomial function, you need to factor it, right? Again, factoring is a major part of this lesson. So, what we're going to do is we're going to look at an example of factoring a higher degree polynomial than just a 2. So here's what we have. Y equals x to the 4th minus 3x cubed minus 10x squared. Since there are 3 terms, it's a trinomial, and the highest degree is 4. So it's quartic. So this is a quartic trinomial. Well, the first thing I need to do here is factor it. And whenever you're trying to factor something with a higher degree than 2, you probably want to see if there's a GCF, a greatest common factor. In this case, there is, because all 3 terms share something in common, and that's x, right? They all have an x. And if you think about it, the greatest number of x's they can share is 2. Because this 10 has 2 x's, right? It could share 2 of them. This has 3 x's, which means it could definitely share 2. And this has 4 x's, also could definitely share 2 of them, right? What's the greatest number they could share? 2 x's. Because that's all this one could share, right? So, remember how that looks. If my GCF is x squared, I will take that out by dividing each term by x squared. And if I do that, I'm basically getting rid of 2 x's, right? So there were 4 here. Now it's x squared, right? There were 3 x's here. Now there's just 1 x left. There were 2 x's here, so now there's no more x's. So when I factor out the GCF, I get x squared times x squared minus 3x minus 10. Well, I'm not done factoring yet. If you notice, I now have a quadratic. And I can factor this quadratic like I would factor any trinomial. So what's going to happen is the x squared is just kind of chilling outside. But I can break down x squared minus 3x minus 10. X squared, well, that's just x times x. Now, this trinomial is the type where, through factoring, I'm trying to find 2 numbers that multiply to negative 10 and add to negative 3. And the numbers that do that are negative 5 and positive 2. Because negative 5 times 2, negative 10. Jesus. And negative 5 plus 2 is negative 3. So, the end result from factoring x to the 4th minus 3x cubed minus 10x squared is x squared times x minus 5 times x plus 2. So I've broken it down into 3 factors this time, right? X squared is the first, times x minus 5 is the second, times x plus 2 is the third. So that's factoring. Now how do I use that to find the zeros, right? So now that I've gotten here, we can go to using our method where I set the y equal to 0. So if I take the y and replace it with a 0, this is what we would get. Now again, think about what you're looking at. 3 things are being multiplied, and the result is 0. That means one of these 3 things has to equal 0. So what I have to do is set each one. X squared equals 0, x minus 5 equals 0, x plus 2 equals 0. So I get 3 very basic equations to solve. If x squared equals 0, what number do you square to equal 0? I'm pretty sure that's 0, right? Wouldn't 0 squared equal 0? So this one, x equals 0. Now, x minus 5 equals 0. Well, if I add 5, I'll get x equals 5. And x minus 2 equals 0. If I subtract 2, I'll get negative 2. So, for this problem, the zeros are negative 2, 0, and 5. So the zeros are negative 2, 0, and 5. So we start by factoring out the GCF. We then factor the remaining quadratic, and then you set each one equal to 0. It's not really that difficult. Honestly, the only reason this would be hard for you is if you don't know how to factor. If you can't factor properly, this is going to be extremely difficult. That's why we spent all of that time learning how to factor, so we could use it in these later lessons. Let's just mosey on along here. Let's talk about using zeros to sketch a graph. Because if you know the zeros and you know the end behavior of any function, then you can have a general sense of how the graph should look. So again, if you know the zeros and the end behavior, you can get a sense of the graph. So what we're going to do is we're by hand, right, without a calculator, going to sketch a graph of x cubed minus 4x. So again, let's just name it. It's a binomial because there's 2 terms, right? The degree is 3, so it's cubic. So it is a cubic binomial. How about we get the end behavior out of the way? So remember, end behavior is going to be based on the leading coefficient. And the leading coefficient is positive, and the degree is odd. So that means my end behavior is going to be down, up. Remember what that means. That on the ends of my graph, on this side, the graph will be going down, and on this side, the graph will be going up. Now, there could be all types of things happening in between there, but again, end behavior. Down means that it's decreasing to the left. Up means it's increasing to the right. And that's all based on the leading coefficient, right? So we have the end behavior. Next, we need to get the zeros. Now, to get the zeros, we're going to have to go through that same process, right? First, let's make y equals 0. Let me write this smaller. Give myself some room. That's better. So, I set the y equal to 0, right? 0 equals x cubed minus 4x. Next, I need to factor. Now, since the degree is higher than 2, right, so it's not a quadratic, I should see if there's a GCF. They both have x, right? So I can factor out x to give myself x squared minus 4. Now that x squared minus 4, that's a quadratic. That can be factored further. And it just so happens to be the difference of squares. So I'll get x plus 2 and x minus 2. So there's my fully factored form, right? Well, I have 3 factors, right? I have x plus 2, and I have x minus 2. So, what I do is I set each one equal to 0. The first one, x equals 0, already solved for us. X plus 2 equals 0, I mean, that's simple enough. You're going to get negative 2, and then if you add 2, you'll get positive 2. So, my zeros, I'll put them in order. Negative 2, 0, and 2. So I have my end behavior down and up, and I have my zeros, negative 2, 0, and 2. So the way this is going to work, I'm going to first plot my zeros. So negative 2, 0, positive 2. See the 3 zeros there? Negative 2, 0, positive 2. Now, think about it. My end behavior is down and up. So, you got 3 points, right? What this means is that before this point to the left, the graph needs to be going down. After this point on the right, it needs to be going up. Because that's my end behavior, right? Down, up. I have down on the left, up on the right. What's happening in between there? Well, again, with what I'm showing you, it's not going to be perfect, but think about it. You have to hit all 3 of these points, right? How are you going to do that? Won't you have to come up, loop back down, and then loop back up? That is a general idea of the way this graph would look. So again, I figured my end behavior out, I plot my points, and then I just need to kind of make it work, right? How do you go from left to right, hit all the points, and make sure that you're going down on the left side and you're going up on the right side? Not really that difficult. As long as you remember those rules for end behavior and you know how to find the zeros. If you have these two concepts down, then graphing should actually become pretty easy. Again, you're going to do a lot of this next year. Like a lot. So I'm hoping we can pick it up now. That way we have a better time next year. And the last thing I want to talk about is how to write a function given the zeros. So instead of finding the zeros from the equation, I give you the zeros and you write the equation. And basically you're working backwards, right? I think this is easier because you don't have to factor. So look at this. Anytime you're given zeros, you can find the equation. And what we're going to do is we're going to write the equation in standard form. It's got to be in standard form, right? Where the degree, the highest exponent, is the first term. And then the next term is the following exponent, right? Like 3, 2, 1 or something like that. So we're going to write an equation in standard form of a polynomial with these three zeros. -3, +2, and +5. So what I want to do is I'm literally going to work backwards. So I'm going to start down here and work my way up to get to here. So how does that look, right? Well, if these are my zeros, couldn't I start with x equals -3, x equals 2, and x equals 5, right? Here's my zeros. Now, usually, these are separated. And if you think about it, how did I get x equals -2? Because it was x plus 2, right? So how would I have x equals -3? It would have to be x plus 3 equals 0. Do you see that? Make it equal 0. If I make this one equal 0, it would be x minus 2 equals 0. If x equals 5, it would be x minus 5 equals 0. You're working backwards. So here, I go from like x minus 2 equals 0 to x equals 2. Well, here I go x equals 2, and I work backwards to make it x minus 2 equals 0. So I work backwards with the equations. Now, where did the equations come from, right? Well, usually these equations come after my factors. So wouldn't that mean my factors are x plus 3, x minus 2, and x minus 5 all equals 0. Basically, when you see the -3, you know it's going to be +3. When you see a +2, it's -2. You see a +5, it's -5. Now, all that's left to do is multiply these binomials, right? I have 3 factors, and I have to multiply them. And that's kind of going to be FOIL method, or a better word for that is distribution, right? So I'm going to distribute x to get x squared minus 2x, and I'll distribute 3 to get 3x minus 6, right? And I can combine like terms to get x squared plus x minus 6. And I still have the x minus 5 equals 0. x minus 5 equals 0. See that? So all I did was kind of FOIL out the x plus 3 and the x minus 2. Now I need to distribute again. So this one, I'm going to set it like this. I'm going to distribute the x. So I'm kind of distributing backwards. That's okay. To get x cubed plus x squared minus 6x. And then I'll distribute the 5. The negative 5, right? So that's going to give me minus 5x squared minus 5x plus 30 equals 0. Well, now all I need to do is combine any like terms. So x cubed does not combine. I can combine x squared and negative 5x squared to get negative 4x squared. I can combine negative 6 and negative 5 to get negative 11x. And I can't combine anything with the 30, so it's plus 30. And how about I change that 0 to a y? So there's my function, my polynomial function in standard form. X cubed minus 4x squared minus 11x plus 30. Again, what did I do? I started with the zeros, right? I worked backwards. So I set each of those equal to 0 like that. That gives me my factors. And I then take my factors and I just multiply them all together. Again, the math involved here, it's basic distribution, right? It's a simple enough process. I know it looks pretty messy, right? I mean, there's a lot of work here. But the work isn't that hard. And that's pretty much everything you need for this lesson. Again, I'm kind of just giving you a little introduction into this stuff. There is more involved here that you'll get into next year. For now, this is all you need. So, number of the day, 665. Got that? 665 is the number of the day. See ya.